Sometimes we need to find all points that are within an area or close to some other points. For example, let's say we are implementing something like proportional editing in Blender here. So if I select a point, then we can move all points that are within a certain distance of that point at the same time. And that's something we want to do efficiently, because let's imagine we have some large mesh here with thousands or millions of points. We can't just check against every other point. That would just not work. How could we do this efficiently? This is where various spatial indexes come in, and I want to talk about such an index today, and that is the so-called RTree or range tree. I'll be linking the paper, the original paper I worked from, in the description. And I'll be partitioning this into a couple of videos. In this video, I just want to give a short overview of what an RTree actually is. And in the next views, we will be looking at how do we query an RTree, as in how do we search an area, how do we insert a new element into this tree, and how do we delete elements from this tree as well. If we look at the original paper, we can find this diagram, and I find it's quite suitable to explain what an RTree is and how it's structured. And in essence, an RTree is just like any other tree. It has nodes and leaves. The actual data objects, so the things we're actually indexing, are always in the leaves. And one special feature of an RTree is that all leaves are on the same depth. So we don't have an RTree never, just a second, looks like this, for example, which is something we can get with a binary tree. An RTree always has, oh my god, I'm messing up, always has the leaves on the same layer. And every node has a bounding box. It doesn't need to be a box, but in the implementation I did and in the paper it is a box. All it technically needs to be is a spatial area where we can check efficiently if something intersects with it or is contained within it. One special thing to note about the bounding box, it's the minimum bounding box. So it's the smallest box that describes the elements in it. And the way we are trying to insert elements and remove elements from here is to maintain a good structure here that allows us to search through this in an efficient manner. I hope I explained that somewhat coherently. If you have any questions, leave a comment.